Welcome to Physics for All YouTube channel. Myself Dr. Reddy Babu. I am going to teach engineering physics syllabus related to the first BTech engineering students. In engineering physics syllabus, we have 5 units. Name of the first unit is wave optics. In this wave optics unit, there are 3 sub-chapters are present. These chapters are interference, diffraction and polarization. These are the various topics of interference, diffraction and polarization. Now, before going to the actual syllabus wave optics, first of all we have to know what is the meaning of optics. Optics is a branch of physics that studies the behavior and properties of light, including its interaction with matter. What is light? Light is a form of energy, makes sensation of vision. It is a part of electromagnetic spectrum that can be detected by the human eye. Light travels with the velocity of light, that is 3 into 10 power 8 meter per second. In this slide, different examples are given for light source. The first picture represents natural light, that is sunlight. Second and third two pictures represent artificial lights. Now, in this optics, basically classified into 3 categories. First one is called as ray optics or ray optics. Second one is physical optics or ray optics. Third one is modern optics or quantum optics. Now we will discuss what are the 3 types of optics one by one. First one, geometrical optics or ray optics. Here light travels in the form of rays or straight lines. It obeys the laws of reflection, refraction, total internal reflection, dispersion and transmission. Coming to the wave of optics or physical optics, here light travels in the form of waves. It obeys all the properties, that is reflection, refraction, total internal reflection, dispersion, interference, diffraction, polarization properties. Coming to the modern optics or quantum optics, it deals with the quantum mechanical properties of light, and here it obeys non-linear properties of light. Example for quantum optics or modern optics is laser light. Coming to the properties of light, first of all we have to discuss about fundamental properties such as reflection. Reflection means when a ray of light incident on any object like polished surface, smooth surface or shiny object, then the incident light bounces back to the same medium, that is known as reflection. In the case of reflection property, it obeys 2 properties. The first law is the incident ray, reflected ray and normal 3 exist on the same plane. It is the first law of reflection. Coming to the second law, always angle of incidence is equal to the angle of reflection. Example for reflection is mirror. Then coming to the refraction property, when a ray of light incident on the surface of medium, then it bends into the another direction. This phenomena of light is called as refraction. Now in the case of refraction property, there we have to observe about laws of refraction. So here if you observe the diagram, here 2 mediums are shown. The lower one is one medium, upper one is another medium. When a ray of light coming from one medium passing into the another medium, then this incident ray bends into the another direction. Now this line is called as normal. With reference to normal, measure angle of incidence and it is called as angle of refraction. Now here this is called as bending of incident light, that is called as refraction. To know about refraction phenomena, consider a glass immersed in a spoon in a water. If you observe, the upper portion of the spoon appears as it is straight, whereas inside of the glass, that is inner part, contains water. The water portion shows bend region. This is about refraction property. Coming to the example of refraction is light incident on the glasses, lenses, or warm water. There are several examples for refraction of light. Coming to the total internal reflection. When a ray of light travels from denser medium to the rarer medium, the incident light at an angle of incidence is greater than the critical angle, then there is no refraction into the another medium. There will be reflection into the same medium. This phenomena of light is called as total internal reflection. To observe this total internal reflection definition, consider the diagrams. In the first diagram, this is known as denser medium, it is a rarer medium. Light is coming from denser medium going to the rarer medium. Then this incident ray bends and travels into another direction. This is called as a refraction. Here theta 1 is the angle of incidence, theta 2 is the angle of refraction. When angle of incidence increases, angle of refraction also increases. If you can increase angle of incidence gradually at a particular angle called as a critical angle called as theta c, refracted ray becomes 90 degrees. Whenever refracted ray becomes 90 degrees, the angle of incidence is called as a critical angle. This condition is required for getting total internal reflection. Once you achieve the critical angle, then again increase the angle of incidence more than critical angle, then this incident ray reflected back to the same medium instead of refraction. This phenomena of light is called as total internal reflection.